Very well. Hello, welcome to today's lecture. This is our last lecture in Math 1B. We're going to continue 9.3 and 9.4, and we're going to have a final on Sunday. Very well. So what we learned so far, we learned about integrals and their applications. So today we're going to start solving a differential equation in a simple format of a separable differential equation. 9.3, separable differential equation. So what is our goal? Our goal is to write a differential equation in the format that all x values are on one side, all y values are on the right-hand side. So this is your goal. Your goal is to write all x terms either in linear format, dx, on one side, and write all y terms like dy. If you have a linear term, just one nomial on one side, on the other side. Then take the integral of both sides. So in general, you can write it this way. For example, you have f of y dy equals to g of x dx. This is an example, general example of a separable differential equation. Then we take the integral of both sides and we start solving this equation. Let's go over one example to see what's going on. We are on page 1. Question says, example, solve the following differential equation. Here you have y prime equals to x squared divided by y squared. First of all, because of equality, you have an equation. On one side, you have the derivative of the function. On the other side, you have x squared divided by y squared. First, use differentiation y prime, which is defined as dy over dx. And replace that here. So dy over dx is equal to x squared over y squared. Then I'm going to multiply everything by dx to get rid of dx on the denominator. I have dy equals to x squared dx divided by y squared. Now I'm going to multiply everything by y squared to get rid of y squared on the denominator. What do you have? You have y squared dy equals to x squared dx. So as you can see, you have f of y dy equals to g of x dx. F of y dy equals to g of x dx. So, since you have a separable differential equation, in the next step, you take the integral of both sides. We have a separable differential equation, we take the integral of both sides. There you go. The integral of y squared dy is equal to the integral of x squared dx. Both of them are easy for you to solve. This is a third. Y cubed equals to a third x cubed plus constant of integration. Okay, at this moment, you're done with calculus part. Now you apply the algebra that you learned before and try to write y in terms of x. So you have a third y cubed equals to a third x plus c. We're going to multiply everything by 3 to get rid of 3. Y cubed is equal to x cubed plus 3 times c. Now we take the third root of both sides to get rid of this exponent 3. So your y is equal to the third root of x cubed plus 3c. For 3c, you can use a new variable or a new constant format. 3x cubed plus, you can call it k. So the solution of this differential equation has the format, the third root of x cubed plus the constant k. What is k? K is another constant replacing 3c. There you go. So I'm going to rewrite this example for you, and I'm going to add another condition to this example. So suppose they have y prime equals to x cubed divided by, x squared over y squared, and you have this condition as well. The question says the initial value is y at 0 equals to 2. We have a differential equation, and the initial value is given as when x is equal to 0, your y value is equal to 2. That's the minimum. So when x is equal to 0, our y is equal to 2. Okay, very good. We already solved this differential equation. We have already solved this differential equation. What do we know? We know that y is equal to the third root of x cubed plus a constant like k. Okay. So it says when x is equal to 0, y is equal to 2. What is k? 2 is equal to the third root of 0 to the third plus k. 2 is equal to the third root of 0 to the third is 0 times 0 times 0. It is 0. 0 plus k. So 2 is equal to the third root of k. So k is equal to 8. Now that you have your k, you can write your differential equation as y equals to the third root of x cubed plus 8. Okay. Let's go over another example for you. We're still on page 1. Now, here you have y prime equals to 6x squared divided by 2y plus cosine of y. There you go. So let's check to see if we have a separable differential equation or not. First of all, you have y prime. Y prime is dy over dx. dy over dx. On the right-hand side, you copy down your rational expression that you have, which is 6x squared divided by 2y plus cosine of y. Very well. What I'm going to do, I'm going to multiply both sides by dx. My d1 is equal to 6x squared dx divided by 2y plus cosine of y. Then I'm going to multiply everything by 2y plus cosine of y to write this on the left hand side. I get 2y plus cosine y dy equals to 6x squared dx. Perfect. As you can see, you have a function in y next to dy, and you have a term in x next to dx. It is a separable differential equation. Well, now we're taking the integral of both sides and start solving this. So the integral of 2y plus cosine y dy equals to the integral 6x squared dx. So the integral of 2y is 2y squared over 2. The integral of cosine y is sine y. On the right-hand side, the integral of 6x squared is 6x cubed divided by 3 plus constant of integration. So you get y squared plus sine y equals to 2x cubed plus c. Can we simplify this more? You cannot isolate y on one side. You can leave it as it is and say, hey, this is my final answer. Or you can write it this way. Or you can say that, hey, I have y squared plus sine y minus c equals to 2x cubed. Then divide everything by 2, and you get y squared over 2 plus sine y over 2 minus c over 2 equals to x cubed. And then take the third root of both sides, your x, is equal to the third root of y squared over 2 plus sine y over 2 minus c over 2. And for simplicity, we use a new constant like k, replacing negative c divided by 2. So x is the third root of y squared over 2 sine y over 2 plus k. And k is minus c divided by 2. Next example. We are on page 2. So question says, solve y prime equals to x squared y. There you go. They have a differential equation. So our goal is to check to see if they have a separable differential equation, get the integral of both sides, and start solving. First of all, y prime is dy over dx, which is equal to, on the right-hand side, it's given as x squared times 1. What I'm going to do, I'm going to multiply both sides by dx. dy is x squared y dx, and at the same time, I'm going to divide both sides by y to write these as separable differential equation. So I get dy over y equals to x squared dx. Do we have a separable differential equation? Yes. This is 1 over y dy, 1 over y dy equals to x squared dx. You have your function 1 over y times dy, and on the right-hand side, everything is in terms of x. Now, we take the integral of both sides and start solving. 1 over y dy equals to the integral of x squared dx. The integral of 1 over y dy, we all know that it's ln of absolute value of y. Guys, make sure you have your absolute value. Equals to x squared, the third, x cubed, plus constant of integration. So we're done with calculus part. Now we're using algebra methods, algebra techniques to try to write y in terms of x. First of all, we call that ln of a function, any function, like f of x, is nothing but log with base e of that function. So you have ln of absolute value of y, which is log with base e of absolute value of y. On the right-hand side, you have a term x cubed plus c. Also recall that if you have log with base a of any function, like f of x, equals to some other number, like b, then f of x is equal to a raised to these two are equivalent to each other. Log with base a of f of x equals to b. It means that f of x can be written as an exponential function, an exponential expression, a to b. So here I have absolute value of y equals to e, the base, raised to this expression. You have a third x cubed plus c. Let us continue. Absolute value of y equals to e, a third x cubed times e raised to c. You have the sum between exponents. Here you have like a raised to n plus m, which is an plus m, which is an times a to n. So I have two exponents. They are added together. It means that we can separate these and write it as e to a third x cubed times e to the c. E to the c is another constant. Let's call it k. Or you can just wait at this step and say, hey, y is equal to, get rid of absolute value, plus minus e raised to a third x cubed times e to the c. And say, I have plus minus e to the c. So why not taking plus e to the c minus e to the c and call it k? Very well. Y, so I'm going to take k plus minus e to the c and write it as e raised to a third x cubed times k, or y is k times e to a third x cubed. So the last thing that we're going to talk about is the solution of logistic differential equation. So first of all, recall that the model of population growth or decay, or the rate of change of population during time, is defined this way. dt, so the rate of change of population with respect to time, change in the population with respect to time, which is t, is defined this way. K times t. And suppose we add an initial value, because we already have an initial amount of a population like p sub 0. So we say that at the beginning time, when t is equal to 0, we have initial amount p sub 0. So when t is equal to 0, the initial amount is p sub 0, which is just a constant, just a number. Very well. Of course, we can solve this differential equation. We have to check to see if it's separable differential equation or not. dp, so let us multiply everything by dt, k, t, dt, dp over p is equal to k times dt. You know that k is just a constant. K is a constant. So now, as you can see, you have a separable differential equation. You can take the integral of both sides. The integral of dp over p is equal to integral of k times dt. K is just a constant. So on the left-hand side, you have ln of absolute value of p, function p, equals to k t plus c. So since you have ln, ln is log with base e. So here you can say that since I have p as population, I can get rid of this absolute value because of population. Population cannot be negative. So you can say that, hey, I can get rid of absolute value for this function. Why is that? Because I know population is not negative. Equals to k times t plus c. So p, or population, is equal to e raised to kt plus constant c. So p is e to kt times e to the c. E to the c is just another constant, so you can call e to the c as c sub 1 or anything that you like. P at time t is equal to e kt times c sub 1. Take a look at your initial value. We know that p at time 0 is equal to initial amount. So if I plug in 0 here, I get e to 0 times c sub 1, and e to 0, a number raised to 0 is 1, so c sub 1, my constant is equal to the initial amount. So the solution for this differential equation is equal to ekt times p sub 0. The solution for the rate of change of population with respect to time. Very well. Now let us talk about the logistic differential equation. For a logistic differential equation, what we had was the rate of change of population with respect to time was equal to Kp times 1 minus mp over. And remember, m was the carrying capacity. Very well. To solve this differential equation, we have to check to see if we have a separable differential equation or not, then take the integral of both sides. So you can multiply both sides by dt. dp is equal to kt 1 minus p over m dt. Then divide everything by p times 1 minus p over m. So here you have dp divided by p times 1 minus p over m equals to k dt. Very well. As you can see here, you have p times 1 minus p over m, and all terms on one side, on the left-hand side, are in terms of p. The rest of them are in terms of t. And k and m are just numbers, two constants. So if you take the integral of both hand sides, you should be able to take the integral. Why not? Here on the left-hand side, you can apply the partial fractions and separate these two. On the right-hand side, it's super easy. It's just kt plus a constant like c. Very well. So let's try to separate these two. You have a divided by p plus b divided by 1 minus p over m. This is equal to 1 over p times 1 minus p over m. There we go. You could say that, hey, I can take the common denominator between these two and write it as m minus p. M goes on the numerator, that works as well. So we can write it as m minus p. And m as a constant jumps on the numerator. M minus p. M minus p. And on the numerator, we only have, for example, m. There we go. So if you take common denominator between these two and add them all, it must be equals to am minus ap plus pb is equal to constant. So what's the meaning of that? It means that negative a plus b is equal to 0. Am is equal to m. So a is equal to 1, and negative a plus b is equal to 0. You already know that a is equal to 1, so b is equal to . Let us continue. So on the left-hand side, we have the integral of 1 over p plus 1 over m minus p dp equals to kt plus the constant like c. Very well. So let us rewrite the integral here. We get the integral of 1 over p, which is ln of absolute value of p. Again, since p is positive, you can get rid of absolute value, plus ln of absolute value of m minus p equals to kt plus c. So what do you have here? You have p times m minus p equals to kt plus c. Ln of p times m minus p equals to kt plus c. Very well. So you have p times m minus p equals to e raised to kt plus c. So mp minus p squared is equal to e to kt times e to the c. So I'm going to factor out the negative sign. I get p squared minus mp equals to minus e to kt e to the c. Now, if you complete the square, you get p squared minus n divided by 2 squared equals to negative e to kt times e to the c minus m squared over 4. There you go. So let us erase this part and write down the rest of it is here. So I'm continuing this part. Okay, very well. So what do we have? We have p minus m over 2 equals to square root of, so let's write down the square root and all the things inside the square root. Negative e to kt e to the c plus m squared over 4. So your p is equal to m over 2, I'm writing this one on the other side, plus square root of. So here you have negative e to c, let me write this right down here, negative e to kt e to the c plus m squared over 4. And inside the radical, you can use a new variable like n, anything that you like. Your p of t is equal to m over 2 plus square root of negative e to c is a new constant, let's call it n e to kt plus m squared over 4, and n is negative e to the c. That's fine, Serena, that's okay. So I'm going to give you discussion on that. Quinn. Okay. Perfect. So again, for this class, it's not very essential. If you're taking differential equation class, these are very important.